Hi guys, welcome back. Today we are going to understand what is ELK stack. The ELK stack is a collection of three open source products. One is Elasticsearch, second one is Logstash, and third one is Kibana. ELK stack provides centralized logging in order to identify problems with servers or applications. Now, when we are developing a project, right? So developers will implement logging in the application. So suppose this is the application. Inside this application, they will implement logging. So here logging means when the application is getting executed, application will generate some messages and it will store those messages inside log file. Application will generate some messages and it will store those messages in the log file. Now, why application should store the messages in the log file? So here, how the application is getting executed, what are the problems that are coming in the application, we need to understand the runtime behavior of our application. If any problem occurs in the application, as a developer, they should be able to understand where the problem is occurred, when the problem occurred, why the problem occurred, what is the root cause of the problem. For that, developers will write the code. In the coding, developers will implement logging also. So logging, what is the meaning of logging? Logging is the process of storing application execution details to a log file. Logging is the process of storing application execution details to a log file. Right. So how application is getting executed, which request came, what information we got in the request, what logic is executed in the application, what response is sent to the client, each and everything will be tracked in the application. For that, developers will implement a concept called logging. Logging is the process of storing application execution details to a log file. Once these log messages are stored in the log file, in future, if any problem occurred in the project, developers will connect to the log file and the developers will monitor logs of the application. Developers will connect to the log file and developers will monitor logs of the application. In order to monitor logs of the application, in some companies, people will go for this Mobile Extreme. Mobile Extreme we can use to monitor the log file, right? Mobile Extreme, how we are connecting to the Linux machine. Similarly, we will connect it to the machine where the project logs are available, they can monitor. And another software is available, which is WinSCP, and another software is available, ELK, and another software is available, that is Splunk, right? So these softwares are called as log monitoring softwares. So developers will write the code. In the code itself, they will implement logging. What is logging? Logging is the process of storing application execution details to a log file. Why application details should be stored to a log file? To monitor the behavior of the application. How our application is executing, when the request comes, what logic is executed, what exception occurred in the project, what errors are coming in the project. Suppose customer is trying to purchase a product in the application, he has done the transaction. So transaction got failed. Why the transaction is failed? What is the problem in the code? All that information will be stored to a log file. Developers will take care of that logging and application will generate that log file. Once the log file is generated, so generally our applications will run in the Linux machines only. So in the Linux machine, log file will be created. When the log file is created, developers should connect it to the log file and developers should monitor logs of the application. So to connect to that Linux machine where the log file is available, developers will use Mobile Extreme or WinSCP or ELK or Splunk. Most of the MNC companies will prefer this Splunk software. Splunk is very advanced and commercial log monitoring software. Okay, if company don't want to go for licensed products, then we can go for ELK to monitor logs of the application. So what is that ELK? ELK stands for Elasticsearch, Logstash, and Kibana. So this Elasticsearch, Logstash, and Kibana are three open source products. Now, what is the purpose of going for this ELK? This ELK stack providing centralized logging in order to identify problems with the servers or applications. When our applications are running, several log files will be created. Monitoring all the log files individually is very difficult process. That's why we need to provide centralized logging for our application so that developers will connect to that ELK and they will monitor logs of the application to understand problems in the application. Once they understand the problem, then they will find the root cause and they will fix the problem. So logging and log monitoring is very, very, very important in the real time, because customers accessing our application, there is a chance of getting problems in the application. When the problem occurred, it will be stored in the log file. Application will store that in the log file. Developers will monitor that log file. Developers will understand the problems in the code and the developer will fix that problem. So in order to do that kind of log monitoring, they need to have a platform to monitor the logs easily. So that's where ELK comes into picture. ELK stands for Elasticsearch, Logstash, and Kibana. ELK stack providing centralized logging in order to identify problems with the servers or applications. It allows you to search all the logs in the single place. Elasticsearch for storing the logs, Logstash for both the shipping, processing, and storing the logs, Kibana visualization software. Let us see. This ELK is the combination of three products as we discussed. Now assume that there are three services available or three applications are running, or one application running in three pods. Those pods are running in three nodes. Now assume that there are three worker nodes are available and my application is running in all the three worker nodes. So you see microservice 1, microservice 2, microservice 3. So microservice 1 is generating the logs, microservice 2 is generating the logs, microservice 3 also generating the logs. So now there are three log files are available. Now developers wants to monitor all the three log files. These three log files are related to one application only. So monitoring three log files separately will become difficult for the programmers. So that's why we are going to use this ELK stack. So in this ELK, the first one is Logstash. So what is this Logstash? Logstash software we will install on the each worker node as a daemon set. I want to install this Logstash on the each worker node. This Logstash is used to read the logs from the worker node and store the logs in the Elasticsearch. So Logstash is responsible to take the logs from the each worker node and store those logs into Elasticsearch. What is Elasticsearch? Elasticsearch is a stateful set which is used to store the logs of the application. Logstash will read the logs from the worker node. Logstash will give the logs to the Elasticsearch. Elasticsearch will store the logs and Elasticsearch will index the logs of our application. Kibana is available. Kibana is a UI-based application. Kibana is providing the user interface for the team to get the logs from Elasticsearch. Elasticsearch, Logstash, Kibana. So the combination of these three softwares is called as ELK stack. So here we understand logging. For every project in the real time, logging will be available. Logging is the process of storing application execution details to a log file. So developers will take care of that logging and project will create the log file and a developer should monitor. To monitor the log files, we need to provide the environment for the developers. That's where, as a DevOps engineer, we are going to configure ELK stack in the cluster: Elasticsearch, Logstash, and Kibana. So what is Kibana? Kibana will provide user interface. Kibana will provide user interface to query the logs. To get the log files, developers will use Kibana. From where Kibana will get the log? Kibana is just UI to display the logs. From where the Kibana will get the logs? So here, developers will connect with Kibana. Kibana will get the logs from Elasticsearch. Elasticsearch is called as a log lake, where the application logs will be stored. Right. So who will give the logs to the Elasticsearch? Logstash will be available. Logstash will be installed on the each worker node. Logstash will get the logs and will give it to the Elasticsearch. Elasticsearch will give the logs to the Kibana. Developers will connect it to the Kibana to see the logs of the application. So now here, same thing can be done by using FluentD. So whatever you can use, either ELK or EFK also we can use. If the logs are available, we can install FluentD. FluentD is advanced to the Logstash. FluentD will get the logs from the log files, will give the logs to the Elasticsearch. Elasticsearch will give the logs to the Kibana. So these three products are open source. These are used for centralized logging in the application. So these three products we can install in our Kubernetes cluster by using Helm charts. Now, our application is running in the cluster. In the worker nodes, our application pods are creating, and application logs also will be generated in the cluster. So now, in the Kubernetes cluster, I need to install this Kibana, Elasticsearch, and FluentD. So let's try to install them in our cluster. So I hope you got the clarity what is ELK and why we need to go for the ELK. ELK or EFK, whatever you want that you can say. Now, so here ELK stack. The ELK stack is a collection of three open source products: Elasticsearch, Logstash, and Kibana. ELK stack provides centralized logging in order to identify problems with servers or applications. It allows you to search all the logs in single place. E stands for Elasticsearch. It is used for storing the logs. Logstash, it is used for processing the logs. K stands for Kibana. It is a visualization software. Similarly, you can go for FileBeat or FluentD also in order to get the logs. Now, EFK installation using Helm. Now I want to install this EFK stack by using Helm. So I have given the commands here in order to set up the EFK stack in our cluster. Okay, let us try to install them. Connect with our cluster. Go to AWS console. AWS management console. Log back in. Yeah. Connected to our machine. Our machine is EKS client machine. Our machine is EKS client machine. In that machine, yesterday we already configured Helm. Helm is a package manager for Kubernetes. By using Helm, we can install our softwares. Whatever the softwares that are required to be installed in the cluster, instead of we are installing them manually, we can ask Helm. Helm is a package manager. Helm will install those softwares for us. Perfect. We are able to connect with our machine. Let us see here. kubectl get nodes. kubectl get nodes. Yes, with this, we are able to connect with our cluster and we are able to get the nodes. 2 nodes are up and running. Right now, let us follow these commands. I'm creating one namespace, guys. EFK namespace, a separate namespace I'm creating. kubectl create namespace EFK. Before that, if you see kubectl get namespace, so currently only the Kubernetes provided namespaces are available. Custom namespace is not available. I'm creating one custom namespace here. kubectl create ns efk. I'm creating a namespace with efk. Right? You can use any name for that. It is a user-defined namespace only I have created. Once we have created this kubectl get namespace, you can check that the namespace is created or not. Yes, you can see here kubectl create namespace efk. Yes, you can see the efk namespace got created. One custom namespace I created, and I'm checking that namespace created or not. Yes, efk namespace got created. Then let us add Elastic to the Helm repository. I'm adding Elastic has been added to our repository. So Helm repositories we have added. Once we have added that, now Helm show values Elasticsearch to Elasticsearch.values. Before going to install the Elasticsearch, I want to get the values of the Elasticsearch. By using Helm show values, it will download Elasticsearch.values file. ls-l. Now if you see Elasticsearch values.file got downloaded. By using that file, I want to edit some values. So here, first I am adding that Elastic to the Helm repository. Then I am downloading. When I execute the Helm show values, so the Elasticsearch.values file is downloaded. That file I'm going to edit vi Elasticsearch.values. In this replicas, I'm configuring as 1, master nodes as 1. So by default, what happened is here replicas 3 available, master nodes 2 available. I'm changing that to 1, 1. I want to keep Elasticsearch as 1 pod and on the 1 node. Now let us save this. Yes, with this I have configured the values for my Elasticsearch. Once I have configured that, then I'm going to install the Elasticsearch by using Helm install. This Elasticsearch I want to install by using modified values file. By default, whenever you execute this, Elasticsearch values file will be downloaded. I have modified some values. I made the replica count as 1, master node as 1. By giving this modified file, I want to install the Elasticsearch in EFK namespace. We created a namespace. Let us take this EFK and let us execute this. I'm installing Elasticsearch under custom namespace. Now you see Elasticsearch got deployed. Elasticsearch got deployed on the namespace. Now go for Helm ls-n EFK. EFK is our namespace. Now in this namespace, you can see Elasticsearch is deployed. Helm ls-n EFK. So whatever the packages we installed by using Helm, I'm able to see those packages by using Helm ls command -n EFK. -n EFK represents my namespace. Now kubectl get all -n EFK. Let us see in that namespace what are the Kubernetes resources got created. Kubectl get all -n EFK. So with this, so here if you see the pod Elasticsearch master is there, master 0 of 1, the status is pending. Elasticsearch master is still in the pending state. For the Elasticsearch master, the cluster IP is created, right? Elasticsearch master, one pod is there, still that pod is in the pending state. Now, Helm show values Kibana. Meanwhile, I'm going to get the Kibana as well. So what is Kibana? Kibana is used to monitor the logs in the UI. Kibana is used to monitor the logs in the UI. So let me go for Helm show values Kibana.values. Now let me go for this Kibana. Kibana values file is also downloaded. Now go for vi kibana.values. Let me change this kibana values. In the kibana values, by default, service type will be available as a cluster IP, but I want to access kibana outside as it is a UI. I will change the service from cluster IP to load balancer. Service type here, if you see, cluster IP is available. Let me change the service type from cluster IP to load balancer. I'm changing service type from cluster IP to load balancer. Now I have changed the Kibana values, and let me install Kibana on this namespace. Let me install Kibana on this namespace. Elasticsearch is used to store the logs. Kibana is used for monitoring the logs. Helm install Kibana. I'm trying to install Kibana on the namespace. Helm install Kibana. It's trying to install the Kibana. It's taking more time. I have modified the Kibana service type from cluster IP to load balancer, and I'm trying to install the Kibana on the same namespace. It should not take this much time.
Ashok, can you open second terminal and see?
Sorry?
Second terminal. another terminal, one more terminal.
Yeah, we can do that.
Let's see get node memory detail address.
No, there is an error. Is not installing that. Let me go with this. Got it timed out. Let's retry. Cannot reuse the name which is already used. Kibana 1. Yes, I think there is some issue with this. It is not getting installed. Let me try a different approach. So I'm stopping this. So it is failing. So let me try with a different approach. So guys, see here, I have prepared one document. Let us follow this document and try to set up the Helm using Kubernetes. So we already discussed theoretically what is a Helm now. And we know what is ELK. Logs will be available. Fluentd should connect with the log files and get the data, give the data to the Elasticsearch. Elasticsearch will give the data to the Kibana. So we are going to download and install below 3 components in our Kubernetes cluster. One is Elasticsearch, second one is Fluentd, and third one is Kibana. So here, let me create one new directory, cd space efk demo, right? mkdir efk demo. So I'm making one new directory to make the configuration files and installations here related to efk. ls-l, it is a new directory. In this, nothing is available. Now, first I need to install Elasticsearch. Elasticsearch will be installed as a stateful set. For that, storage is required. So for that, I'm going to create one storage class first. So that storage class is available here. Let me take this storage class, open this with the VS Code IDE. This is my storage class. Namespace I'm giving as logging. First, let me create a namespace logging, kubectl create ns logging. I'm creating one namespace with a name called logging. Let us see the namespace is created or not. kubectl get ns. Now you can see my namespace is created. I have given the name as logging. So with this, I'm going to create one storage class, right? So I'm giving the kind as a storage class. Class name I'm giving as dev storage class, and the namespace is equal to logging, right? So in this document, so here I have given what is the storage class that we need to create. Let me take this storage class and create vi storage class.yml. Now, so by using this YML, I will create one storage class, API version, kind, metadata, name, namespace is logging, and save this file. Once that file got saved, let us create that storage class by using given manifest YML. So let us create that storage class. Already we have created the YML, kubectl apply -f storage class.yml. So I have created one storage class by using that YML. So we can check that storage class is created or not by using this get sc. We can do that by using get sc. kubectl get sc. Storage class is created or not. We can see here storage class is created. Dev storage class got created. Volume binding immediate mode. Fine. Once it is done, namespace already we created for the logging. Storage class is created, and we are able to check the storage class is created or not. Namespace I have created already. Then create persistent value manifest file using above storage class and a namespace, and then apply it. I need to create one persistence value. In that persistence value, I need to configure the storage class that we have created, and the namespace we need to configure. So here I'm having persistent value, that is pv.yml. In this pv.yml storage class name, what we have given here, the storage class name we have given as dev storage class. So let me give that class name as dev storage class. Namespace we have given as logging. Namespace we have given as logging. Now API version v1. So if you see here, this is my YML file here. This is my YML. API version v1, kind is persistent value, name. So we can give the name as Elasticsearch master. For that, we can give the name Elasticsearch master. Elasticsearch master. Namespace I'm giving as logging. Labels you can give for that. So labels I'm giving as app Elasticsearch master. The name of that and pod label I'm giving same. Spec capacity, storage is available, and access modes, read writes, storage class name, dev storage class we have created, and path I'm giving as the temp. Now storage 20G is available here. I'm giving here 4 GB. That is fine. So this is my storage class with a persistent value. Let me take this volume file and let me create a PV, vi pv.yml, persistent volume I am using, right? So I'm giving this PV. Let me save this and apply this. kubectl apply -f pv.yml. So I'm trying to create the persistence volume by using this pv.yml. With this, our persistent volume created. Once persistent volume is created, check the PV created or not in this namespace. kubectl get PV -n logging. Our namespace is logging. In that namespace, our Elasticsearch master is created. The status is available. Persistence volume is available. So once it is available, then download and extract the Elasticsearch using the below command. Command to download Elasticsearch. So here I have done 2 steps, guys. First one is I created one storage class, dev storage class with the namespace logging. Then once the storage class is created, with that storage class, I have created a persistence value that is used for storage, right? My Elasticsearch should store the data. For that, I am using persistent value for that, and I'm giving storage class for that. So once it is done, the next step is we need to download and extract Elasticsearch using the below commands. So I have given this command, wget command. Let us copy this command and download Elasticsearch in our directory. So let us see here, wget, this Elasticsearch is downloaded. Once this Elasticsearch Helm file is downloaded, let us extract that Elasticsearch file by using this tar command. So you can see ls-l storage class YML is available, PV YML is available, and Elasticsearch is also downloaded. Now, once it is downloaded, let us extract that Elasticsearch software, which is downloaded as a tar file. Now, not this, so tar Elasticsearch EFK demo. So tar command I need to execute, tar-xvf, I have given that. Then it has extracted that tar file, ls-l. Now you can see this Elasticsearch is available. It is extracted that Elasticsearch directory. Once it extracted that Elasticsearch directory, now we need to go inside the Elasticsearch and edit the values in the YML. So by default, we don't get the storage class attribute. We need to add it with the storage class that we have created. So now here we are going to edit this YML. So how we are going to edit this YML? In order to edit this YML, we need to see here, storage class file is available. Go inside the Elasticsearch directory and edit the values.yml. Now, this is my Elasticsearch directory, cd space Elasticsearch. I'm in the Elasticsearch. So this is the Helm chart that we have downloaded. In this Helm chart, values.yml file is available. Let us go for vi values.yml. In this values.yml, we are going to configure storage class, right? So storage class name will not be available by default. Volume claim template we need to configure. Replicas 3, minimum master nodes 2 available. Let me configure replica as 1 and minimum master nodes as 1. Then come to volume claim template. Yes, here volume claim templates available. In this volume claim template, by default, that storage class is not available. So we need to configure that storage class. After access modes available, let's enter. Let us configure storage class name. So what is our storage class name we created? We created storage class with a name called dev storage class. You can give any name for that. And storage here 30 GB available. Let me change it to 5 GB. I don't have that much space, right? I have changed it. After we have modified this YML, then we need to save this YML and we need to install this YML. Now save this file. Then execute this command in order to install Elasticsearch with the modified values. Earlier, directly we installed by using Helm chart, but the problem is with the persistent value, it is facing an issue. Elasticsearch pod was not able to create. Now I have downloaded that Elasticsearch chart. I modified the values. I configured my storage class. And now I'm trying to install that. Okay, let us copy this command and let us try to install that file. Helm install Elasticsearch repo -f values with a -n logging. So with this, I have installed Elasticsearch under namespace logging. Once after installing this, now next one, we need to download FluentBit and we need to install. Currently, I'm in the Elasticsearch directory. Let me come out from this directory, cd space, right? Now I am outside of the Elasticsearch. I went into this Elasticsearch directory. I modified the values YML and I installed the Elasticsearch by using Helm chart. Right, next one, FluentBit installation I need to do. I came out from the Elasticsearch directory. Then let me download FluentBit with this URL, wget command I'm using. With this, FluentBit got downloaded. You can check it, ls-l. Now, my FluentBit file is downloaded. Let us extract that file as well, tar-xvf, right? That file got extracted. Now you can see ls-l here, FluentBit directory is there, cd space FluentBit. In this, you can see the chat, Helm chart got downloaded. Here also values.yml is available. FluentBit is available. Now we are not going to modify anything in the FluentBit, guys. Go inside that and directly install the YML as it is. Here for FluentBit also values YML is available. You can check the values YML, values.yml. You can see what is the kind, daemon set is the kind. So FluentBit, what is the role of the FluentBit? FluentBit is used to collect the logs and give to the Elasticsearch. So FluentBit should be installed on all the worker nodes. That's why the kind is a daemon set. Replica count is 1. So the FluentBit is getting installed. FluentBit is getting installed as a cluster IP, and it is having daemon set. FluentBit pods will be installed as a daemon set, and FluentBit service will be exposed as a cluster IP. Why they are using daemon set for that? The daemon set is they want to install the pods in all the worker nodes. That's why they are using this as a daemon set. Now let us install our FluentBit. Helm install FluentBit. Copy this command and execute this. Not this. Now this command, Helm install FluentBit with values YML in the logging namespace. I have not modified any values here. So with this, our FluentBit got installed. FluentBit got installed. My Elasticsearch is installed. My FluentBit also installed. Now, once it is done, then let's come out from this FluentBit directory. Now I am in the home directory. Where is my EFK demo is available. Then finally, I need to download and set up Kibana. So to download the Kibana, this is the URL, wget URL. Now fine. So we are able to get that Kibana. So once we have downloaded the Kibana, let us go here and extract that Kibana tar file. Extract Kibana tar file. Once we have extracted the Kibana tar file, now you can see Kibana directory is available. And guys, remember all the downloads I am doing from my directory called EFK demo. First, I downloaded Elasticsearch. In that, I modified values.yml and I created that. Then I came out from that directory and I downloaded FluentBit and I installed FluentBit. Then I came out from that. Now I have downloaded Kibana. Now here I should go inside the Kibana directory and I need to edit the values YML and change the service type and node port. Okay, you can give it the node port or you can give it as a load balancer. Now let me go inside that Kibana, cd space Kibana. So this is Kibana directory, ls-l. Kibana also downloaded as a Helm chart, chat.yml, templates available, values YML available, vi values.yml. So this is my Kibana. You see, Kibana, what is the role of Kibana? Kibana should get the logs from the Elasticsearch. So if you see in the diagram, so logs will be available. Logstash will get the logs from the nodes, Logstash or FileBeat or FluentD. I'm using FluentD. Right. Now here, so logs will be collected by FluentD and FluentD will give the logs to Elasticsearch. Elasticsearch will give the logs to Kibana. So Kibana should connect to the Elasticsearch. How Kibana will collect to Elasticsearch? You see here, Elasticsearch URL is configured in the Kibana values file. This is the URL of our Elasticsearch. Whenever you install the Elasticsearch, it will run by default with the 9200 port number. So Elasticsearch host is configured in the Kibana values. Right. With that, Kibana will connect to the Elasticsearch. That is the mapping. Come here, service section will be available. In the service section, by default, it will be available as a cluster IP. Service type is available as a cluster IP. Let me edit this service from cluster IP to load balancer. Right. I changed that service type from cluster IP to load balancer. Then I want to install my Kibana. So once we have changed it, that's here I mentioned it as a node port, but I change it to the load balancer. That is fine. Once we have done that change, then we need to execute Helm install Kibana with the modified values under logging namespace. Copy this. Now install Kibana. Yes, Kibana got deployed. Now you can see the status. My Kibana also deployed. Then clear this. Once it is done, now let us see all the services that are available under this. And the pods services under our logging namespace we can verify. kubectl get the service -n logging. Now you can see that Elasticsearch master, Elasticsearch is running as a cluster IP, as a headless service because it is a stateful set. FluentBit is running as a cluster IP and it is a daemon set. And Kibana is running as a load balancer. And this is the load balancer URL. Kibana by default will run on the port number 5601. Okay, the default port number of Kibana is 5601. The default port number for Elasticsearch is 9200. So these are the services that we have created now. Let us check the pods. kubectl get pods -n logging. Now I'm trying to get the pods here. FluentBit pods are there and Kibana pods are there. Elasticsearch pod is still in the pending state. So FluentBit pod is running. Kibana pod is also in the running state. Once these pods are in the running state, now let us try to access our Kibana by using its load balancer URL. So this is the load balancer URL for the Kibana. Let us try to hit that URL. So I'm trying to hit that URL. That is the load balancer URL. So by default, it will be running on the port number 5601. So let me try to enable that port number. Go to load balancer. Go to load balancer. We created one new load balancer now. That load balancer is created for Kibana. So just now one load balancer got created. Let us open this load balancer. Check the security group. Check the security group of this load balancer. This is the security group of that load balancer. Security group ID, inbound rules. Add the rule 5601. Is it enabled? 5601 is enabled on that. Load balancer URL 5601. It is not running. So once we access that Kibana, we should get a dashboard like this to monitor the logs. By 601. No, it is already enabled here. Another security group. Security group ID, inbound rules. Yes, I'm not able to access the Kibana URL. The Kibana dashboard should come as I have shown you in the document. So once we have installed the Kibana and changed the service type, when we hit the Kibana load balancer URL, we should be able to get the dashboard like this for the Kibana. Once we get this dashboard, we can check the logs of our application. But here, I'm not able to get that. I'm trying to check it. Why there is an issue. kubectl get pods -n logging. So here I think the issue is with the Elasticsearch. The Elasticsearch pod is still in the pending state. It is not getting into the running state. Kibana pod is also not ready. 0 of 1. Let me check the logs of the Kibana. kubectl logs of this Kibana pod -n logging. So it's logging namespace. Yeah, Kibana log issue. Kibana logs. I'm trying to check. The issue with this is error. Elasticsearch service unable to retrieve version information from Elasticsearch nodes. Connection refused. Yes. Kibana is not running. The reason is Kibana is not able to connect with the Elasticsearch because the Elasticsearch pod is not updated. The Elasticsearch pod is still in the pending state. Now you can see that I'm in this home directory. Now kubectl get pods -n logging. Now the problem is here. Whatever the pod that we created with the Elasticsearch pod is not in the running state. So as we discussed, Kibana should connect to the Elasticsearch to get the data. Kibana pod is also not created. You see the status Kibana 0 of 1. I want to create one pod for the Kibana, but the Kibana pod is in the 0 state. That means the Kibana pod is not started. Why the Kibana pod is not started? Kibana pod is trying to connect with the Elasticsearch pod, but Elasticsearch pod is not created. So there is a problem with the Elasticsearch pod. So see, Elasticsearch pod is still in the pending status. Elasticsearch pod is still in the pending status. kubectl get stateful set -n logging. So here Elasticsearch master I am trying to create, that Elasticsearch master is not created. Still it is in the pending state. Let me delete this. kubectl delete kubectl delete sts Elasticsearch master. I'm deleting -n logging. With this, Elasticsearch master got deleted. Elasticsearch is not getting created as expected. Get pods. Now you see Elasticsearch pod is not available. So cd Elasticsearch ls-l. Here values.yml, chat.yml is available. We are trying to create the pods for the Elasticsearch. PV created, applied it, pv-n logging. Elasticsearch is done. Storage class configured and storage also configured. After modifying the file, we are trying to create Elasticsearch repo with the modified YML, fluent bit, node port, SVC, get pods. So when I executed Elasticsearch pod was running, but now it is not running. Check it. ls-l vi values.yml. Let me check the value. Volume claim template requests I have given dev storage class. Replicas 2. Port number by default 9200. It is cluster IP. Let me try once. Guys, I'm trying to delete the Elasticsearch chart which is created. Helm ls metric server, it is available. Helm install or Helm upgrade. Now I have upgraded Elasticsearch. Let us try. Is it creating the pods or not? Elasticsearch pod should come into running state, then only we can check that. kubectl get pods -n logging. No, Elasticsearch pods are not coming to the running state. If the Elasticsearch pods are not in the running state, then our Kibana cannot start because Kibana should connect to the Elasticsearch master. Elasticsearch master pods are not in the running state. They are still in the pending state. kubectl get PV. My persistence value is bounded. It is good. Dev storage class. I have configured the storage class as well. No. Still they are in the pending state. Guys, I think there is some mistake. I need to look into this, why it is not working. Manually, we can't change from pending state to running state. So there is some issue with our pod creation. So that's why it is not in the running state. It is in the pending state. So as per this diagram, Elasticsearch pod is not getting created. If Elasticsearch pod is created, then FluentD can give the data to Elasticsearch. Elasticsearch can give the data to Kibana. My Kibana pod is trying to connect with the Elasticsearch, but Elasticsearch pod is not created as expected. So there is an issue. But I think when I prepared this document, it worked as expected. I have taken proper screenshots also. So if you see here in the pods, so my Elasticsearch pod got created. 1 out of 1, the pod was running. Once the Elasticsearch pod was running, then Kibana pod started and it is also in the running state. At that time, I have taken this screenshot. Right here, I can see the Kibana dashboard is accessed and we can monitor the logs in the Kibana dashboard. So I will look into this issue, why my Elasticsearch pod is not getting into the running state, guys. I need to fix this issue. Yeah, now I can't show you the log monitoring because there is an issue with the Elasticsearch. Now, who will install this ELK in the real time? Yes, DevOps engineer should install this ELK and should set up the ELK, and developers will only monitor the logs by using ELK. Developers will access the dashboard using the given URL. Once they access this dashboard, then they can monitor the logs. To show you the dashboard, my Kibana pod is not started. See here, 0 of 1. 1 pod should be created, but 0 pods are created. The reason, Elasticsearch pods are in the pending. Kibana should connect with the Elasticsearch. That is not happening now. Yeah, guys, so with this, I will stop now because we can't proceed further with this. I need to do some analysis why it is not working. So in the next class, I will update on this. I need to check what is the issue. So when I prepared the document with the same process, I was able to do it, but now it is not working. I need to look into this and I will update the document if anything needs to be changed, and I will share that. Any questions? Anyone?
Ashok, this Nagarjuna.
Sir, can you share that those two documents? Maybe we will also. Meanwhile, we can also try
you can also
it
try.
at our end.
Yeah, I will share this document in the portal. You can try meanwhile. I will also try from my end today. So by tomorrow, I will try to resolve this issue.
Ashok, this Nagarjuna.
Hello,
Yes,
sir.
sir.
Yeah, actually, if you don't mind, if you go to the document where we are during the logs, see, actually here we are checking the 5,000 some port number, but in the URL, it's showing to the 30,000 like that. I'm suspecting. If you don't mind, you can observe the clearly.
No, sir. In the URL, no. So when forget about the URL, first of all, when I'm checking the pod status, right?
Yeah,
So
yeah.
here itself it is failed. No need to go with the URL.
Okay.
Yeah, here only you can see 0 of 1. Actually, it should be 1 of 1.
Okay.
0 of 1 means we expected to run 1 pod, but 0 pods are running.
Okay.
Why Kibana pods are not running? The reason Elasticsearch pods are in the pending.
Okay. So that services we can't start them manually, or if you have any issue, how we can troubleshoot like that if you don't know.
Yeah. So I'm thinking the issue with the Elasticsearch pod creation, some persistent volume storage classes are not bounding properly. I will do some analysis and I will get back to you in the tomorrow.
Yeah, okay, thanks.
Okay. One thing, this is a good example. Suppose that in real life I want to troubleshoot these pending pods. Okay, why it is in the pending state? How I can check in the kubelet side API server SQL?
You see, yeah. So now you see this pod is in the 0 of 1. What is the meaning of 0 of 1? 1 pod should be created. But how many pods are created? 0. Why this pod is not created? We can check the logs of this pod. You can check it. kubectl get pods -a and logging. So let's take the Kibana. Kibana is not up and running. What is the reason for that? kubectl get pods, kubectl get logs or kubectl logs pod name. That pod is in which namespace? That is in my logging namespace. Okay. Now, when I check it, I got the log. So what is the log it is saying here? There is an error. What is the error? Unable to retrieve version information from the node. Connection refused. So with which it is trying to connect? Elasticsearch, it is trying to connect. Elasticsearch will run on the 9200. My Kibana is trying to connect with the Elasticsearch. As the Elasticsearch pods are not created, my Kibana pod is not started. So this is the log that you can see, and we can understand the issue here. Connection refused.
So we cannot troubleshoot the pending state pods.
No. So if you have the pod, then only you can go for the pod log, right? But in the Elasticsearch, those are the stateful set pods. Master pod and replica pods will be available. We can't troubleshoot them now. I can't go to the log of this because it is saying that pod is not available. If I execute a command on this, kubectl logs with this name -n logging, it will not give me anything because with that name pod is not available because still it is in the pending. Once your pod comes to the running state, then only you can check the logs. This pod is still in the pending. So in the cluster, this pod is not available. So you can't check the logs of that pod.
Ashok, this ELK setup is one-time process, right?
It is one-time process. In the project, it is one-time process.
Okay.
Yeah, I will check that, guys. I will check it and get back to you. Okay. Thank you. We'll see you tomorrow.
Ashok, that is 0/1 means it's running or 1
0/1 means 1 should be created, but 0 are created. 0/1 means our pod is not running. There is some problem in the pod. Here,
but
if you see,
when it 0 is created, its status is showing as running.
Yes, man, the pod is running, but it is not up. Pod is here. If you see Elasticsearch pod status pending. Pending means not created. Kibana pod is created. Pod is running, but there is a problem in the pod. Pod is not ready to use. That is the meaning of 0/1.
Okay.
Success and total. Success pods 0. Total 1 pod should be created. If you see fluent bit 1/1. Fluent bit pods are running. Elasticsearch pods are not created. As Elasticsearch pods are not created, Kibana pod is failed.
Okay, got it. Thanks.
Hello, sir.
I think we will try to make this Elasticsearch run. Once Elasticsearch runs, I think Kibana should work because the connectivity between Kibana and Elasticsearch is not there. That's why Kibana is failing, right?
Can you come again?
I mean, it seems like Kibana is not starting because of the Elasticsearch issue. So if we will troubleshoot the Elasticsearch, it will the Kibana.
Yeah, we need to troubleshoot the Elasticsearch. We need to troubleshoot the Elasticsearch.
Right.
Hello, sir.
Yeah, hi.
So, sir, what is the difference between fluent bit and log stash Same
Sir,
or?
yeah, both are same, sir. Different softwares, both are same.
Okay, both are different software.
Yeah.
And so one more thing in that that error which you are getting, if you go to that Elasticsearch directory, that YML file you have given at YAML. So if we change to YML, will it
No,
work?
no, no.
Values?
YML or YAML extension, both are same.
Okay, okay.
Both are same.
Okay, sir.
Fine, guys. Thank you. We'll discuss in tomorrow's class. I will do analysis on this. Have a great day. Bye-bye.